Assalamualaikum and good day everyone. So before this, you were introduced to architectural patterns that can be applied during architectural design. In this chapter, we are going to continue with design patterns which can be applied during detailed designs. So the topic that we're going to discuss in this chapter is creational design patterns. The discussion on the creational design patterns are split into 3 sessions. In the first session, you will see the overview of design patterns and then discuss one of the example of creational design patterns, which is called abstract factory. In session 2, we are going to discuss about the factory method, and session 3, builder, prototype, and singleton. Now, we move to the first session, overview of design patterns and abstract factory. So in these sessions, the agenda is to discuss about the patterns in detail design, and we will see what is the difference between architectural and design patterns. And then we will see about the classification that exists for design patterns, how to document design patterns, and then later we continue with creational design patterns, which is called one of the example of creational design patterns, which is called abstract factory, with a computer store example. The design patterns that we're going to discuss in this chapter or in this course is taken from Gamma, Hans, Johnson, and Blizidus, better known as the Gang of Four. That's the catalog 23 detailed design patterns. Actually, their work inspired by Christopher Alexander's work on architectural patterns for building. Christopher Alexander is not a software architect, but the building architect that published a catalog of building patterns, more than 200 building patterns in 1977. And then Gamma or Gang of Four took the example from here in terms of the format, how to capture design patterns and to be used by other software architects. So they use a specific pattern specification formats. Okay, so what is the difference between architectural and design patterns? Actually, patterns, as long as it is patterns, so they serve the same purpose. They speed up the design process, have the same vocabulary for communication, reduce design errors, etc. So they share the same benefits. But what are the differences between architectural and design patterns? Okay, the first one is architectural pattern take place during architecture activity, during architectural design. And the design patterns is during detailed design. And then architectural patterns too abstract to be translated directly to working code. But for design patterns, they have a class specification for us to implement, especially when we use object-oriented programming. So, and then another one is architectural pattern have direct effect on the architecture of the software. So we have learned about different types of the system, interactive systems, distributed systems, so on and so forth. So they have a direct effect to the architecture of software. But design patterns, no direct effect to the software architecture. So to summarize, I use these illustrations. So the architectural patterns, we use it to do the modeling at the abstract and conceptual level. And then we further refine our design into the detailed design we can use design patterns. Actually, there is another patterns, I quote patterns or idioms, which is outside the scope of this course. So this one you can search Google, and then you will find that the code the code also have the patterns. So this one is towards implementation. So from the abstract or conceptual world to the implementation world. So this is a different, so that you can have an idea about what is the difference between architectural patterns and design patterns. Okay, so for the design patterns, we can classify based on purpose or based on scope. Based on purpose, we classify into creational design patterns, structural, and behavioral. For creational design patterns, we study the patterns that deal with the creation of objects, the way we create the objects. to simplify or to solve certain problems that we are going to discuss. Each pattern have their own problem that they solve. For structural patterns, deal with the creation of structure from existing structure. And then behavioral pattern is about the dynamic aspect of the system. It is about the behavior, how the class interact, etc. We will see later in the next chapter for the structural and behavioral. In this chapter, we will discuss about the creational design patterns. That is the category or classification based on purpose. Another classification is based on scope, whether it is the class scope or object scope. For the class scope, it is during design time. So object scope is during runtime. That means the creation of the object is only known during runtime. But we do not use this classification. For this course, we will use the purpose specification. So for this chapter, we'll discuss about the creational design patterns. Okay, another thing that is important is actually the way to document design patterns. So there is a standard way to document the design pattern so that we have a uniform description of each pattern. Even if you want to introduce the new design patterns, you can use this format. But for this course, we are not going to use what we call this document design patterns, but we just needs to know about what is important elements need to be captured in each design patterns. For example, the pattern needs to have name and classification. The name and classification, whether it is structural, behavioral, or creational. So it has a unique name. And then the intent, what is the purpose of having this pattern? And then also known as, it is an alias, maybe it's known as the other name. And then motivation, example scenario that we can use to describe the patterns. Applicability, so what is the situations, the problem that we are going to solve using that patterns. For example, for the abstract factory, when we want to create the new object based on the existing, the structure of based on the runtime, for example. And then for the structure, it is very important. It is like a UML class diagram for each pattern. And then inside that structure, they have a participants, list of classes. So you must be able to know the structure, to draw the structure of each pattern that we discuss in this class. And then the participants, to describe. The participants is a component inside this structure. And the rest, collaboration, consequences, implementation, sample, code, known use. I think that's one. It's very straightforward.